Welcome to Chapter 1 from the chemistry course. As I mentioned in my introduction, we are going to be integrating the CLEP test. I have the CLEP review book for chemistry as well as the super review. We'll integrate that into our course. We also have the AP chemistry crash course as well. So whether you need tutoring for chemistry or you're studying for any of these tests, let me know and I can guide you along the way. Chapter 1, Measuring Up. That's what the first chapter of the book is focused on. And we're going to talk a little bit about units of conversion as well as matter and measuring distance and so on and so forth. So let's start from the top. Matter is anything that has mass and takes up space. Matter is anything that has mass and takes up space. I have the book here and we're just going to follow along. The key units that you need to know in the broad scheme of things are two categories of units. We have the English units and the metric units. Almost every country of the world uses the metric except 3 countries: America, Liberia, and Myanmar. Well, actually, or Burma, right? So Myanmar. Only 3 countries do not use the metric system. Someday, we hope that that would change, but at this point, that's the case. So you need to be comfortable with converting units from centimeters to meters, meters to centimeters, and so on and so forth. Here's a quick example of unit conversion. If someone says convert 20 centimeters to inches, then what you need to do is you need a relationship between the two things that are being converted, and then you write down the value you were given, 20 centimeters, and here you write down wherever the centimeters are, and in the numerator you write down the inch above there because that's what your answer is going to be at the end of the day. When we're done with this problem, we should have inch at the end there. So this is 20 centimeters, 2.54, and then you basically take your calculator, 20 divided by 2.54, and that will give you the answer that you need. This is one of the key examples on converting units. Your book talks about significant digits. You need to be comfortable with understanding what a significant digit is and what those rules are. If you have any questions on significant digits, please just send a message about significant digits. Otherwise, we'll do some practice on that. We can do some practice on that later. Okay, so the units of conversion, very important. Being able to convert centimeters to inches and inches to centimeters. Your book in example 1.4, they actually use 20.12 centimeters. That's pretty cool because I just made up a number, but your book has that 20.12. The work there came out to 7.921 inches. Remember, the only thing we have to worry about is the number of significant figures in the original measurement. It has 4 in the original measurement. Therefore, they left their answer there in 4 significant digits as well. The prefixes are very important. We have mega and kilo and hecto and deca, centi and milli and micro and nano. And you're going to see that in my Tools for Mastering Math resource, which I'm actually going to send to my chemistry students as well. Understanding how many zeros are you dealing with. It's something 10 to the 6th power or 10 to the 3rd power, right? So just being comfortable with what those numbers mean. So I'll send you the reference booklet of chapter 2 or part 2 of our book, and it will guide you along the way. Experiments are not covered in this course. I will encourage you to look at those experiments, but once in a while I might give you some details that relate to those experiments. When you measure, I just want to mention a couple of things here as you go through chapter 1. When you measure something, we talk about the meniscus. The bottom of that, if you think of it as like a U, that bottom spot is usually the point that matters. And so if this is 10, right? If this is a cylinder of a sort, this will be 10 there, and this could be like 5. So if someone says, well, how many milliliters? So milliliters, this would be 10 milliliters. We use the bottom of that U. That is very important in lab work that you'll be doing on your own or with a group of friends. That's always good to, maybe you could go to a friend's house and do like an experiment party, like a good party. That's a good party. A party where you guys do good experiments, right? Experiments that your parents will approve of, and maybe over the kitchen counter you talk about measurements. That would be a cool thing to do. Okay, so be comfortable with unit conversions, and then make sure you practice the skill that is given to you. You have the chapter reviews, and then you have the comprehensive checks as well. Key definitions. Density. When we look at density, which we have a letter that we use to represent density, remember that's mass over volume, right? Density is mass over volume. We've talked about matter. Let's talk about mass. Mass is a measure of how much matter exists in an object, and weight is a measure of how strongly gravity pulls on an object. When you talk about weightlessness, notice that when you move out of the region you're in right now, the weight could be something that changes on a body. But so you talk about things like weightlessness, but the mass is the same. So what we need to be asking people, at least when I was younger, I remember they used to say, you should be asking people, what's your mass? Not what's your weight, they would say. But honestly, it wouldn't matter as much here on Earth. But I think if someone comes up and says, what's your mass? Now you know why they're saying that. It would probably not be polite to say, what's your mass, though. It doesn't sound as cool. Density, as we said, is the mass over volume, or it's a measure of how tightly packed the matter in a substance is. How tightly packed, right? So now you're dealing with mass, the matter in a substance is. So please write down the definitions, and then for the examples, that's actually a good skill, is also writing out the examples. If you have any questions on those examples, let me know, please. Finally, what happens if someone gives you the mass of something and the volume? How do you find the density? If someone gives you the mass and the volume, how do you find the density? Well, if the mass is 10 kilograms, so you say mass over volume, and the volume is 1,000 milliliters, right? So you can go with mass over volume in this calculation, right? The other way you might see, or the units you want to be using, grams per centimeters cubed. When we deal with volume, we're going to have cubed. When we deal with area, we're going to have squared. And then when we deal with perimeter, we're going to have the first power. So notice first, second, and third power. Units are very important. So for density, it would end with like grams per centimeter cubed in a standard form. And so you should be comfortable converting these units to their appropriate counterpart. So kilograms converting to grams, milliliters converting to centimeters cubed, and so on and so forth. Let me know if you have any questions. This is just an overview video of chapter 1. We can dive into the specifics after. Take care and have a blessed day.